Welcome, everybody, to another series for datastorage.com. I'm here with a special guest, Brian Geisel from Geisel, as well as Symage. Welcome.
Yeah, thanks for having me.
Absolutely.
Awesome to be here, man.
The first thing I always like to do is just kind of jump in and get a little background on yourself, and then potentially, start out with Geisel because you've got a couple of companies here.
Yeah, sure. So I sort of grew up an engineer, so I come into this from the engineering background, and sort of grew up in the storage world, doing some stuff for digital equipment and compact and multipathing and all that sort of stuff. And then in 2011, I started Geisel Software. And so Geisel Software is a software development company focused in and around robotics, AI machine learning, connected devices. And so we do the software on all those kinds of things, really focused on solving hard problems, whether that's multi-agent systems on other planets, or it's working on the fastest warehouses in the world. That's kind of our jam at Geisel Software. And then Symage spun out of that, as you mentioned, and Symage really was a spin out because as we got more and more into robotics, we were doing more and more computer vision. A lot of robotics has been trending that way. You can do your SLAM, simultaneous localization and mapping. So as the robot's moving around and understanding where it is, doing that a lot more with computer vision. And so we ended up doing a project with NASA to help their rovers move more autonomously on Mars. And so how could we do that? So they wanted to train a model, but there's no data on Mars. And so we created a synthetic Mars, and in that, I guess, sort of a digital twin of Mars is what we're going for, right? And to give them data so that they could then train on that data and then eventually move it to Mars and see how well that compares with the data that they were able to, synthetic data that they were able to train on. And so that ended up spinning out into Symage, which is now focused on various types of synthetic image generation.
Very cool. So with Symage, are you just focused on image or do you have multimodality?
Yeah, we do have multimodality, and we have a few within images that we can tie into, and I can go into that a bit, but also video. And then there's sort of this other side that's doesn't fit as closely as image and video. And on the other side is things like tabular data, but we're doing some interesting things in what I sort of say it's almost like the Sim City, where it's generating synthetic people who have synthetic lives. So they have children, spouses, and families, and occupation, and where they live, and all this sort of thing. So you can imagine you take those sort of things, and now you say, well, what I need is IRS tax forms. So we can generate IRS tax forms now out of these sort of synthetic individuals, or a workflow at work. They're working on a project together. What emails would they send back and forth, and Jira tickets and whatever's happening there, those kinds of things. So there's a bunch of other things you can sort of generate from that synthetic world, writing synthetic code, some other things that are outside of the image video side of things.
Very cool. And I'm guessing now that companies are all kind of adopting AI and even potentially even building models, that synthetic data has kind of taken on a greater demand. Is that the case?
Yeah, it's really come on. I think it was almost a year ago now that Jensen was talking about it at the CES keynote and talking about how important synthetic data is. And I think that woke people up to like, oh, this thing's kind of been around, and people didn't know too much about it. And people kind of went, okay, it's in a keynote. We should know about what this is. And so I think in the last year, we've really seen teams starting to employ it a lot more.
Yeah, I heard a quote by Elon Musk about how, we're almost at the end of compiling all of the data off the web. Like there's no more data to be compiled, right? And so he actually mentioned that, X is going to start basically creating synthetic data to continue to improve their model. And so do you think that's going to be a common theme across all the foundation models, that they're going to start consuming synthetic data to continue to iterate on what they've built?
Yeah, I don't think it makes sense to continue without synthetic data. On the other hand, I don't think it makes sense to not use real world data. We should be using that. And so I think there will be rare cases where you'll use 100% synthetic data. The Mars
Yeah.
example, when you just can't get real data, you're going to use synthetic data. But I think you're right. I think a lot of the foundational models are going to need synthetic data because you can so much more precisely target things that the model's struggling with, and you can hit areas that are either hard to reach with real data or impossible to reach with real data or dangerous to reach with real data. So I do. I think there's going to be a lot more synthetic data for those kinds of things. And I think one of the things you see in any of the LLMs that are out there is say how good they are at coding. They're really good at a lot of those things, but within narrow windows. So if you get them to do, this is 2025,
Time flies.
and so let's pick C++ 27.
Yeah.
They're not going to be very good at that because there's no training data on that. And so whenever a new programming language or model framework comes out, those kinds of things, there isn't any training data yet. And so from that standpoint, they'll always lag behind developers who are actually humans writing the code because they have to generate it first before the model can train on it. Well, if you can generate synthetic data, then they can learn before the full body of work exists.
That's really cool. So you guys at Geisel have been at this, in robotics and ML and AI long before it became, I guess, the norm. How are you seeing the shift now that there are these really powerful foundation models? How are you seeing the shift in the capabilities of robotics?
It's it's moving very fast, and I want to emphasize it's moving very fast. It's moving slower than the speed of AI overall, though, I think, because you still have this hardware component. You still have this physical world component. And so the robot still has to turn the door handle or whatever that is in the physical world. And so some of those things moving things in the physical world are just hard in ways that take time. But I think it's accelerated. I think it's moving. Robotics has been moving fast. I think it's moving faster than it was. I would put it a notch down from how fast we see just AI and ML moving in general. And so, yeah, it's interesting. We talk about, physical AI now and the things that we're able to do with AI in the real world because of what I'll say very broadly is robotics. I don't think we might always consider that traditional robotics and some of the things we can do in the natural world. But if we just turn robotics into the term of any time the computer can touch the real world,
Yeah.
right? Then this idea of physical AI is really interesting and something that's, again, sort of given us new capabilities, very similarly to the way LLMs, like all of a sudden it was a new building block that was a thing we didn't have before. There were times where you just needed a human to look at a thing and make a decision like this text, yes, it's positive or it's negative. Now an LLM can do those kinds of things. So we're introducing the same thing on the robotics side now, where before it was like, if you can give me the exact parameters and I can write an algorithm to say what the robot should do under those parameters, fine. But if I, the human, never thought of it, then the robot can't do it.
Yeah.
All of a sudden, when you introduce AI and AI specific to LLMs, right? It doesn't only have to be LLMs, but again, you can kind of use the LLM as a problem solving thing. And so take the actual data of what's happening on the robot and say, look, here's the situation. I have this robot that can move this far and that robot that can move this far, and this has the capabilities. But what I need to do is get things between two stations on the moon. What could I do to solve the problem? I couldn't do that in traditional coding if I didn't think of the problem before it happened.
Exactly.
But now if it's happening in real time, yeah, I could use something like an LLM to sort of problem solve and go, you know what? I'm going to use these capabilities in a way that the developer of this never thought of. And I think that's a whole new world.
Yeah. Yeah, I'm guessing that, both in the world of your robotics business, where there's probably a lot of video monitoring across those different robots and applications. And then on the synthetic side, you're creating images and videos. I'm guessing a lot of those end up being high resolution. Those can be pretty large files. So how do you guys solve the problem of just storing all of that data?
We're working on a good solution to it right now.
Yeah.
I don't think, boy, this solution we have is perfect and we're all done now.
Yeah.
I think it's interesting because you have a couple different things, right? On the robotics side, I went to a talk recently, so I'm going to steal this from whoever it was that was speaking that I apologize. I don't remember, so I can't credit him. But he said there's two main problems with data in robotics, and he was 100% right. He said, number one is we don't have enough data in robotics. And number two is we have too much data in robotics. And what he meant by that was we're generating, like you said, video feeds. Maybe I have 6 or 8 cameras on a robot that are all recording, and the robot's sitting in the corner idle, and they're all just recording. I don't need any of that data.
Yeah.
And then another robot comes whipping across the wherever we are and runs into my robot. So my robot may have been in an idle state the whole time. Now all of a sudden that video is super important. What happened? Why did it run into me? And so this thing of like, I don't want to save 8 cameras of idle time, but then all of a sudden there's an accident or something anomalous. All of a sudden they need that data. And then on the synthetic data side, it's another one of these not totally unique, but interesting problems in that way, in that we're generating gobs of data. You're going to train your model on it, and then you don't need it again until you train your model again.
Yeah.
So do you store it locally and just ready until you train your model again? Or do you keep it in the cloud? Do you delete it and then, right? So what do you do with that data? And I think I think there's an opportunity there to come up with a good way to manage that storage.
Yeah. What we see a lot of the time is, um, when you're building your model, you want that data sitting on that high performance storage as close to your GPU as possible. But what we try to educate people on is you want to only have that data there for as long as you absolutely need it. The minute you're not using that data on that high performance storage, right, there should be let's call it an object store, whether it's on-prem or in the cloud, that you can basically take the data from high performance storage, move it back to the, we'll call it like low cost, high performance object storage, where it can remain there until you need it again. But the challenge there is that you really have to find an object storage that can have really high throughput to move it from place to place. And so we found some providers offer as high as a terabyte a second throughput, so that like you can move, hundreds of terabytes or petabytes in hours or days rather than months, right? Because time is of the essence in this game, right? So that's something that we've seen, and there's a lot of really amazing companies outside of the hyperscalers that offer that, because as we know, right, egress can become a challenge, right? Sending data from one place to the next. I'm wondering, do you guys, when you're transferring all of this synthetic data from your platform to a customer, how do you kind of tackle that issue of egress?
I think right now we just get it done. And I think roadmap is find a better solution for that for customers. And like I said, for that, when they need it again, and are they going to store it locally right now, this kind of thing. And so right now, really, it's a customer issue for us. And I think I'd like for it not to be in the future.
Yeah. Yeah. I think, going back to the robotic use case and the synthetic or just any type of data, it's always been like, what data do we need? You even mentioned that earlier. We don't need that data, but if there's an anomaly, we might need it. And I think that companies have been so used to this framework that the hyperscalers set up, where to store data, it's expensive. To move data, it's expensive. And so it's like this game of cat and mouse, where us as partners to our customers or vendors, we have had to help educate them on what data they should keep and what data they shouldn't keep. And I don't actually feel like that's the best methodology. I think that the more data, the better.
Yeah, I was gonna say, like, the issue, right, is it's expensive to keep it, it's expensive to move it, it's really, really expensive to not have it and need it.
Absolutely. Yeah. I come from in my past life, we worked with go-to market data a lot, and companies would come and they'd say, "Hey, I have one data vendor or two. I already have three data vendors. Why do I need a fourth data vendor or a 10th data vendor?" I'm like, the more data, the better. The more data you put into your product or your analysis, the more you're going to get out of it, the more value you're going to create, and ultimately, the more money you're going to be able to make.
And the number of things that we've seen that as technology improves, the data that we used to have for images, let's say, low resolution, same with video,
Yeah.
much to us today, right? Low resolution. And so now we're like, okay, well, I got it in 4K. And for some things, we might say, we're going to train our model on 720p, so we'll just store that. The problem is in 2 years, when models are performing better in XYZ and we have more GPU power, and you don't have the data
Yeah.
anymore at the quality that we had it at, and all of a sudden the model would be better if you had that or whatever it is.
100%. Yeah. Let's kind of switch gears into what are the use cases today where you're really seeing, um, we'll start with robotics, right? What are the use cases where you're seeing a lot of success? What are the verticals or industries that are really having a lot of success? I mean, I know that we all want like the Elon Musk like robot that's going to help, cook and do homework with the kids and stuff. But like, I still think that that's pretty far out. And I know that there are successful use cases. What are some of those use cases that you guys have seen and helped companies with that, are really dialed in?
Yeah, and I think I have a bit of a polarizing view on this because I think humanoid robotics are stupid.
Yeah.
Uh, the way we work as humans works really great for humans. But when we're trying to solve different problems, we waste a lot of energy just staying upright, staying balanced, all these kinds of things that you have to put into a humanoid robot. And then you put a vacuum on the floor and it can get under your couch and it saves all the energy of having this 100 kilogram beast walk around and carry additionally a vacuum cleaner. And so there's a lot of cases where the robot for the particular problem is really the way to go. And you end up having more robotics, but they're more specialized to the problem. And so we're definitely seeing warehouses. You see it today. If you think about the things you've had from Amazon, where it was revolutionary that they could get things to you today.
Wild.
You could buy this extra membership and get things today. And now you can get things today,
Yeah, that's true.
right? They're not anymore 2 days away, but later today or tomorrow morning at 7 a.m. or whatever it is. That really has a lot to do with the robotics in warehouses and how much it's not only the robotics in warehouses, there's a lot of other strategic things that they've done to make that happen, but it has a lot to do with the robotics in warehouses. And we're seeing more development in manufacturing and warehousing.
Yeah. I had my team go through an MIT course for AI and business strategy. And it was from MIT. One of the courses was about the robotics in warehouses. And what they mentioned, there's all this commercial real estate right now that is unoccupied, right? After COVID. And it's come back quite a bit, but there's a ton of space out there that's just unoccupied. Companies don't know what to do with it. And in this course, they're talking about how, in the past, it was always like you wanted as much square footage in your warehouse as possible because the more room you had, the more capacity you had, and the more orders you could fulfill. But what they were talking about is with the rise in robotics and smart robotics at that, and specialized robotics that are built for tasks, they're building like these micro warehouse slash distribution centers within any geo, right? And it could just be like one of the offices down the road that has, 4,000 square feet, has a really specialized set of robotics in there fulfilling orders for that geography that doesn't have the need for a 10, 100,000 square foot warehouse. And so they're actually like creating these micro warehouses in strategic locations run off robotics to fulfill the needs of that customer base more efficiently. I thought that was super cool.
Yeah. And we're seeing all sorts of companies in that area, whether it's like that provide some sort of situation where the robot can kind of do an elevator thing and go into
Yeah,
different sections so it's tightly packed. And we've even seen companies that are on the opposite side of that, where they're doing things that robotics aren't great at yet. They're great at, if you know what it is, it's well organized, this kind of thing. But what about companies that don't know what the inventory is that they're
yeah,
getting? And that's their specialty. And so they get a box of random things into their warehouse, who are actually buying more warehouses
yeah,
because they aren't able to sort it all. And so it makes them more money if they buy in more warehouses and just keep filling them with the piles of junk. I'm sure they don't think it's junk, but
yeah,
right, more disparate objects in big piles. Where if you could make use of some of the new abilities of robotics, they shrink their footprint drastically.
yeah. Yeah. So, um, again, maybe we switch gears to the synthetic data side, right? Are there verticals or use cases that today you're seeing are just like dialed in and companies are investing in them? Like, what are some of those, can't miss use cases?
I think the first there's a few, I guess, kind of obvious ones. One is in computer vision and getting computer vision models better. So think about, there are lots of different use cases, but if you think about autonomous driving,
Yeah.
it's maybe one of the easiest ones for us to all imagine and or see it if you're using one of the vehicles that has some of the autonomous driving.
Yeah. I was in a Waymo in San Francisco last week. It's crazy.
Yeah, yeah. And you see the things they're really good at and the things that they get confused
Yeah.
by, or that they're less efficient, right? That they just slow down where a human would be able to navigate it easier. And so, how do we improve those things? So, one of the things that's amazing about synthetic data is you can focus it right on the problem. And if you think about it, like think about a wide receiver in the NFL and how they train. If they trained the way they play a game, they'd be terrible.
Yeah.
You think about how does that work for an average wide receiver in an average game? They maybe get the ball thrown to them once for average,
Yeah.
right? So in an hour game. So if you had an 8-hour practice and somebody throws you 8 balls, you're not going to be a great wide receiver.
Yeah.
You want ball after ball after ball after ball after ball. We should be doing the same things with our data. So the things that are hard, no one cares how long he spends half his time jogging to the sideline and jogging back. We don't need to train on that. We want to train on there's a ball in a weird spot and he has to twist his body to get his arm to it. We need to do exactly that with our data is what are the pieces, where are the situations where the model's not doing well? Where the model would have to metaphorically twist its body and rotate the right. What are those things for the model? What are those things when something anomalous comes out on the road? There's a ladder on the road. Can I just drive over it? Do I drive around it? Do I go into the other lane? No, there's a car in the other lane. How do I train on ladders on the road? That's not a thing that I get a lot of photos or a lot of video footage of. And so you focus your synthetic data on those kinds of things. We say the grandma problem. Like, we don't want, if grandma runs out in front of a car, probably grandmas are smarter than that. But situations where really where a car hits a human, I'm sure that the companies that do this have some data on that. Thankfully, they don't have a lot of data on that. And obviously, we don't want to just start flinging humans in front of
Yeah.
cars so that we can get the data, right? So what do? Well, synthetic data is a great way to focus on those things that are dangerous.
Yeah.
And so those sorts of things that can be dangerous, anomalous, hard to get to, we want the model to still be good at those things when that thing comes up, but it's not the thing that normally comes up.
Yeah.
And so it's a funny thing to think about, but if you have a balanced data set, you have a bad data set because the balanced data set is the one catch per game.
Yeah, it brings up a good point, which, I've always, since I learned of the, kind of explosion of synthetic data, I was just thinking like this is going to create so much more storage, right? So much more data is going to need to be stored because of, now we're creating data. But when you speak about it like that and kind of going back to the conversations earlier, it's like we're already in live scenarios to get the data you need. You've got to basically record, hundreds or thousands of hours of normal activities to get the
Yeah,
10 hours
right,
of the activity that you're actually training on.
right.
And so there's really potentially in this case, like we're creating more waste in some cases by taking live, real information and disseminating it down to what we need than we would if we just synthetically created as many of those data points that we needed without all the waste. So do you feel like synthetic data is going to add to the world's like data storage problem, or is it potentially going to help not have to store so much data because you don't, need to basically capture everything to get down to that little piece that you need?
Yeah, I think the thing you're getting to exactly right. I think it's both.
Yeah.
I think you'll have situations where today we think about getting models better by having more GPU.
Hmm.
Mm, What if we can generate the right synthetic data and we think about getting models better by having enough storage to add enough of the right
Yeah.
kinds of additional things? And then to contradict myself, there was I think it was a recent publication in maybe Nature where they trained with synthetic data and they were able to reduce their reliance on real data by 70%.
Wow.
So by hyper focusing the synthetic data on the things they needed, they were actually able to reduce their overall storage of it. And so I think you're going to have situations that are both, like obviously generating synthetic data is new, so we're generating additional data. We're going to need a way to
Yeah.
store that and good ways to manage it. I think that's for sure. But I think also it can also be a solution to being able to reduce the storage footprint by hyper focusing on the things you need. And like you said, you have less data waste
Yeah.
for some of these other things of all the real data that I stored and then when I'm done making that argument, somebody else is going to go, but then 10 years later, I needed all that data that I stored and I threw it away because right.
Just don't throw it away.
Yeah, right. Yeah,
Yeah. That's the whole reason, data storage is here. I think that it's datastorage.com is working to help people understand that there is a transition that's happening today. We're going from this, on-prem to SaaS, and now SaaS to artificial intelligence. And um, when we were in that SaaS and on-prem world, we didn't even though we knew we needed it and we backed it up, like we didn't know how to use it. Like we didn't have the tools to digest it all and make sense of it all. But now it's like with these large language models and all of the progress that's happening in machine learning, that data can be utilized, right?
yeah,
And I think that's just amazing. But you just really have to be very cognizant of how you're storing it, who you're storing it with. And that brings me to my next point with you. I'm guessing that you guys work in some regulated industries like, synthetic data for healthcare or synthetic data for, maybe defense or government contracts. And so my question first is, to create synthetic data, do you need to access the first party data of the party you're working to create it with, so that you can model around their first party data? Or can you just create synthetic data without having access to that information?
The way we're doing it, and I think that's part of the uniqueness of us, we do not need access to their data
Wow.
in order to generate synthetic data. And so that fixes almost all of the problems of the regulation. In health data, right, you have PII,
Yeah,
personally identifiable information. Well, when you take the P out of it, then there's no more PII.
yeah,
So when there's no real person that you've generated this data from, then your PII is safe. And so healthcare companies that can't touch any data because of PII, they can't train on any of the data, or they have very limited controls and very limited which data they can get access to. It makes it super hard for them to employ AI in a lot of places. You bring in synthetic data, there's no P, no PII, all of a sudden they can train on this stuff, no problem.
yeah,
There's no regulations against people that don't exist's information. Now, there are data techniques where if you're using Gen AI, for example, and you're training on real people's data and then outputting something, then there's a different situation there. If you're doing augmentation techniques where you take real data and you manipulate it in some way so that the data that output is still following that initial inputs parameters, but now the data is different. The the name of the person is different than the data and what they have and what they're so forth. Those get into all sorts of complications around the regulations and how do you solve for that.
yeah,
So there's a lot being figured out there. But in the case where, and I will say one thing that sometimes for us, it is helpful to look at the data, but in the way that a human would like look at it and go, okay, I get it. That makes
yeah.
sense. I understand what that is. And so sometimes that can be a problem where, say, data is classified and you don't get to look at the data that's coming in. And so how can you generate data that's going to help train that model well? And usually that turns into more of an iterative approach to get there.
Very cool. Yeah, maybe a little bit more about Geisel and Symage. How big are you guys? And do you see growth potential on both of the businesses that it kind of equals, or do you see that one or the other is like, primed over the next couple of years to really see some exponential growth?
Yeah, I think, and the reason we really spun Symage out is because I think we see exponential growth opportunities in both, but in very different ways.
Yeah,
And so Geisel really focused on the robotics side, and we've been able to do some really interesting things for some of the largest companies in the world, NASA, these kinds of things, solving really hard, unique problems. And I think that puts us in a great position for some of the new things that couldn't be solved before. Like I mentioned, where you need some sort of thought in the process. And now we could use things like LLMs, or we're starting to uh, do things in robotics and experiment with them at least, where you would do kinematics. So kinematics is like you or I, if we say, keep your hand level as you move it forward,
hmm,
we just do it. We don't
yeah,
think about it. But the robot is moving the wrist, it's moving the elbow, it's moving the shoulder, it's rotating those to keep this
yeah,
flat. So we do inverse kinematics to get that to work properly. And there's lots of math that we do to
yeah.
do that. Some people are trying now replacing that math with training a model to do it and going, forget about solving the algorithms to do it. Here's what I want to do. You train on all the different ways to do this, and then I'll just hand it to a model that will make it move straight.
That's very cool.
And then you translate that into into picking up an object or picking up a weird object. And so you start to get into all those sorts of things that you might get the model to perform better. So not just an LLM angle into robotics, but all sorts of other forms of machine learning that all of a sudden you can apply to robotics problems. And I think on the Geisel side, gives us a whole new world of ROI to explore for customers
Yeah,
and get us there. On the Symage side, it's really focused on this product of synthetic data. And I think what we're working with customers now is to find out, again, where are those big ROIs for things? What are the things where we can make a huge, huge difference? Is it on the image and video side? Is it on the simulation of people side? Is it on generating different aspects of things that the LLMs ingest and kind of hyper
Yeah.
focusing on some of that versus, things like trying to make a billion Reddit posts. Like, I'm not sure that's a great use of synthetic data
Yeah.
sometimes.
Yeah, it's true. I'm wondering, do you guys have your own, are you building your own LLM to create the synthetic data? Like, are you using mostly CPU, or do you have GPU utilization to actually create the synthetic data?
So I almost nothing will I rule out
Yeah.
because as you learn, you come up with different things. Uh, but my plan is really there's some great LLMs already. Let's
Yeah,
use them.
I agree.
I have no intent on creating new wheels. Let's use the great wheels that are there. And you even have options like OpenAI will let you refine their models with your own data. And so you can use some of those aspects. So no, and in fact, one of those things that I've changed on a little bit is I started with we will not use Gen AI under any circumstance because you have these artifacts. If you see it in images, every single person you ask Gen AI to give you a selfie, two things you'll see. Number one is in the image of them taking a selfie will be this. You never see that. You never see the phone in a selfie,
Yeah, it's true.
right? You just see the person. But if you ask it for a selfie, you will see the phone and they will have one, two, three, four, five, six fingers, right? We get those kind of artifacts from
Yeah.
Gen AI. And so that's how you know I'm real, folks. I have the right number of fingers. Apologies to anyone who has extra fingers. But you get those kind of artifacts from Gen AI. And so I was like, no Gen AI. But now we're starting to find where the right fit for Gen AI is there's a lot of things you don't want to use it because of those artifacts. But let's say we're generating 100,000 living rooms for someone, different angles, different living rooms, different structures, different layouts, and they have TVs on the walls or they have painting on the wall or a tapestry or I don't know, whatever and you want variation. Well, Gen AI might be a great way to put something on the TV that makes
Yeah,
sense.
absolutely.
And really, your model training on the living room, if the guy on the TV has six fingers, not going to ruin your model probably.
Yeah,
So there are cases where it makes sense. And so I think the same thing for some of these other things is there are places where they'll make sense as we keep developing, those things will come in and make sense.
very cool. Well, I think, we've really enjoyed the conversation today, Brian, and the audience out there, many of you are developing solutions or training your own machine learning models, Gen AI, doing Gen AI, building LLMs, and if you haven't already started investigating the synthetic data use cases that can improve your models and potentially lower the storage, and if they provide more, make it so there's more storage, it's just going to improve overall the outcomes. And so, um, if any of you want to, learn more about Symage or Geisel, what is the best way for people to kind of do some more research on you guys?
Yeah, catch us at geisel.software
Okay.
and simage.ai. And we're on all the social media platforms. So, connect with us on LinkedIn, TikTok, Instagram, Facebook, X. We're there.
You've got your own podcast too, right?
Yeah, yeah. And Solving for Tomorrow is the name of the
Very cool.
podcast. And yeah, check that out. We just all sorts of people doing different things
Yeah.
that are so different than us, that are looking to what's tomorrow look like in this industry and that industry.
Absolutely. Well, we've really enjoyed having you today, and look forward to seeing how you guys are going to help push this market into a direction where both the robotics side of it and the strength of the LLMs continue to improve because of the synthetic data you're creating and then the development work you guys put in on the other side.
Yeah, thanks, John. This has been great, and yeah, I think there's some really interesting future ahead for all of us here.
Absolutely.